suppose one is like with some angle theta 1 with the suppose x axis. I want to say that this is x axis. So this angle is like the angle between this dipole direction and the x axis, right? And another has some angle theta 2 with the same axis. And they have like this, the other angle is, look, this has the same angle with this, but if I rotate this, it has the same angle again with this. But the angle with this axis, this has changed. This was 0 before, and this is the angle 0, the planes are. What should I say? This is the angle, the planes are angle change. This is the azimuthal angle, right? So, आगे कर दूसरे में azimuthal angle सारे तो that's supposed to be like that for the 5 day essentially. Azimuthal angle is some phi or whatever, but what I mean that they are fixed. They are not moving. Phi is constant, theta 1 is constant, theta 2 is constant, right? So I will just write the final expression for that direction energy. Do not, I don't want to go in detail how to derive it. Just to write it that has been calculated by the book mu1, mu2 divided by 4 pi epsilon r cube and 2 cosine of theta 1 cosine of theta 2 minus sine of theta 1 sine of theta 2 cosine of phi. That has been calculated the energy of two fixed dipoles with angle, the zenith angle theta 1, theta 2 and the azimuthal angle phi. Right? The relative azimuth angle is suppose phi. So from here I see that if this is fixed, this is fixed, this fixed, this fixed, this fixed, this whole thing is constant, right? And R is the separation. So I can see that the energy between two fixed dipole varies is 1 over R3. So the energy between the energy between a charge in a dipole was varying is 1 over R square, and the energy between two charges varies as 1 over R. So this is kind of a change. The energy between a charge and a dipole varies as 1 over R square, and the energy between two dipoles varies as 1 over R cube. So the energy between two dipoles sharply drops. Two potentials are dropping. Look at 1 over R cube. Now the energy between charge.
Sir, that theta 1, theta 2 only phi. Theta 1, theta 2 phi. This is what it is.
Come here. Which is the difference? That's theta 1 theta angle.
Yes, sir.
That's the polar coordinates.
Yes, sir. Say
That's
double theta 1, double theta 2.
That's theta 2 is equal. That's the equal.
G.
That's theta 1 day. See that? So that's a come. Beyond theta 1 day.
Yes, same thing.
So that angle phi. They choose this one.
Yes, sir.
Charge and a rotating dipole. Energy between a charge and a rotating dipole. They will be rotating. cannot be fixed because of the thermal energy. We cannot confine a dipole to a certain angle. Among simplicity, the part are fixed hook.
Yes, sir.
But they are under constant motion because of the thermal energy. Right? The thermal energy provides them the kinetic energy, and they are in motion. So we are going from simple to complex. In that situation, right? The dipole, this is a dipole, right? So we can say that this dipole can rotate like this. This angle can change at the same time. This can rotate like this as well. So at the same time, this angle, right? If I want to
Horizontal or vertical?
yeah, to have the azimuth angle that will phi, so it will be rotating as well like this in this plane,
Horizontal.
right? So three there are the surface is defined by two angles theta and
Polar coordinates.
and so it is rotating. It is allowed to rotate, right? So that in this case, the energy is WR is equal to minus Q is the charge, Q square as a dipole moment square, 6 pi 4 pi epsilon whole square and KT and R to the power 4. Right? That is the energy between
Charge and
a charge and a rotating dipole. Right? A charge and a. Now we are going toward the important factors contributing to the van der Waals forces. Huh? The dipole interaction of this is no. Root 2. Now we are going to the factors of which the van der Waals forces are made. Given to balas panel. Contribution to van der Waals interactions. Contributions to van der Waals interactions. Right? I'll read a bit of your more keys of interactions. Key some right? Interactions. Keys of interactions. Keys of interactions are interactions which are between two rotating dipoles. Between two rotating dipoles. Sorry? Interaction between two rotating dipoles. Right? For example, this is a dipole with dipole moment Q1, and that is with dipole moment Q2, right? R is the separation between So this is allowed to rotate like this, as well as to rotate like this. Similarly, this is allowed to rotate, right? They both are allowed. Huh? The interaction between them between two rotating dipoles minus mu1 mu2 squares and over c 4 pi epsilon whole square kt into r to the power 6. نص خبر ده تمام واورده ايه the interaction energy between two charges varies as 1 over r. The interaction between a charge and a dipole varies as the interaction energy between two fixed dipoles varies as 1 over r cube. Now the interaction energy between rotating dipoles varies as 1 over r to the power 6.
دي كيف صار انجل منشن نشوف انجل بيجي منشن نشوف فرموليك
rotating the canal and the constant another allowing average values.
شو كم previous one fixed
the angle average values rotating it constantly. The rate integration شباب the rate average values average over period. Angle large quantitative current average values over the whole period. The fine or the other fixed number angle values. So to rotate key beyond the rate average values to angle average. सही ना? हर प्रकार हर पाई प्रकार value और मतलब या 2 pi pi one divide to the average. सही ना?
Yes.
So here 1 over r to the power 6. So the interaction energy between two free dipoles, the interaction between free dipoles under the action of thermal energy. Thermal energy. كم شيء ناس تتنبري thermal energy نبري. أغير وجه قليل. So this energy or this interaction is called Keeson interaction, and this contributes to the van der Waals forces. Keeson interaction. We were talking about fixed dipoles. One contribution to the van der Waals force comes from fixed dipoles. Fixed dipole, I mean molecules having a dipole moment. Fixed condition geometrically specific fixed. Out of freeway for the day باقاعدة without an electric field day باقاعدة full magnetic moment. Electric moment, sorry. Like a water molecule for electric moment. So, between two water molecules, the interaction, there is a van der Waals interaction. Because there are two dipoles and they are free. What's simple atoms هغه خپل فکس dipole moment نشته فرض کړه نیوټرل
जी
صحیح ده داسې symmetrically distributed charge is symmetrically distributed suppose the negative charge is symmetrically distributed around the positive charge center so it will have zero dipole moment
yes
but the dipole moment, a dipole moment can be induced in this neutral end. As I told you the other day, that if you put them in an electric field, the center of positive charge and the center of negative charge will split.
right
They will separate from each other and they will contribute to the dipole moment. They will produce the dipole moment.
induced
That is called induced dipole moment. Right? So,
the interaction between two water molecules keys of interaction
keys of interaction. Right? So now we are going to enter action, right? Or let us first say what is an induced dipole, right? Moment. An induced dipole moment. सही है? So you put a non-polar molecule. You put a non-polar molecule. Non-polar means the
negative
the center of positive charge coincide with the center of negative charge. That's called non-polar. So when you put a non-polar molecule in an electric field, there develops a dipole moment. And that dipole moment is directly proportional to
Right.
the electric field, the center of the field, right? Mu induced is proportional to E, the electric field. Or we can say mu induced is equal to alpha and to E. This alpha is called molecular polarizability.
polarizability
Molecular polarizability. सही है? ध्यान हो ना alpha का सिंबल ना? Mu induced divided by
electric field
the electric field, right? No, आमतौर से ये non-polar molecule का ना polar उसका non-polar उसका से non-polar molecule ये आगे induced polarization कुछ produce. No, आगे we denote it by alpha 0. Right? For non-polar सब किताब बुधा से लगती है let us understand it through simple atom. Understand it through simple atom, right? Atomic polarizability or electronic polarizability, right? Simple atom. We call it electronic polarizability. Again, किसको बोल जाऊँगा? Electronic polarizability. Electronic polarizability. Electronic polarizability, right? मसलन जो है Çınar koyuyor bir. Burası. Darası. Now, when you apply an electric field in this direction, we are the first line. No, there is electron orbits they are attract or the other center of the positive charge. सही है ना? तो हम कोई ना इलेक्ट्रॉन है उधर हम सर पर इसका प्रोटॉन ये तो मतलब E plus होगा हाँ जो radius है वो है that displacement का solution हाँ बाकी that bar line coincides the charge and here was this the rotating suppose electron, classically speaking. Now when we apply the electric field, now the charge is here, positive nucleus, and the electrons are orbiting here like that. Right? And I can write this phenomenon here like this. That is the positive nucleus, right? And that is the diameter of the orbit of electron. So if this is like theta, we call this is theta, and I call this separation is L. The separation of the center of the radius of the diameter from the nucleus, that is L. The induced polarization. The center of negative charge is this, and the center of positive charge is this, and they are separated by a small distance which we call L. Right?
Yes. Yes, sir.
That's what induced dipole charge multiplied by separation.
QE.
That is called the dipole moment. And also, if we look at this through the mirror of equation 1, the atomic data induced equal to alpha naught and 2. Because this is atomic, so therefore we write for alpha naught. Now we say like this is now here is an external force. External force is defined by a charge multiplied with this electric field.
Yes.
You have put the weight of an external electric field, and there is an external force on the electrons orbiting around the nucleus, we can say. Right?
Yes.
But there is an internal Coulombic force as well between the nucleus and the electron. And finally, this external force and the internal force will balance each other. And that will be called the equilibrium. This is now the equilibrium situation. After the displacement, this was the first equilibrium position. But after the application of the
Field.
electric field, now this is the new equilibrium position. So, under equilibrium, we equate the external force to the internal force.
Yes.
Huh? F external is equal to F
Internal.
internal.
QE is equal to.
सही है ना? Huh?
Yes, sir.
Huh. From this منتظر each reckoner منتظر E for R cubed as induced. Routine منتظر this U induced solution down برابر 4 pi epsilon R cubed and the under equilibrium. Under equilibrium, this is equal to that situation. Yeah, alpha naught. So it's a super equation. If you compare this with this equation, so alpha naught will be equal to 4 pi epsilon naught into r cube. Say that. Atomic polarizability super equation is directly proportional to r cube. Right? This is r. What is r? This is r. So atomic polarizability. This is r. This one is what? Atomic polarizability is proportional to r cube. Now, the polarizability of a polar molecule. The non-polar, okay? Say that? The polarizability of a polar molecule. Polar molecule لطرفها polar molecule are rotating freely. The time per every ceremony was per period polarization is 0. The Kayo Kedasi, Nimpir Kedasi, and Nimpir Kedasi. No, that's when you sum it over time, the dipole moment is C. Because dipole moment is a vector quantity. When you sum it over time, it will have 0 dipole moment. Right? Average dipole moment. Okay. In an external field, if you put it in an external field, right? Then, as we said, if you put it in an external field, there is a net dipole moment. That's different. Alpha marlumas control, there was net dipole moment. That's it. And an external electric field, it will have a dipole moment. So what is this for a molecule, right? If we have done an atomic cake, our molecule cover. Induced is equal to mu square divided by 3 kT of E under the action of electric field. E is equal to, where E is equal to external field. Where E is an external field. Our U today is the permanent dipole moment. This is permanent dipole moment. Permanent. Induced dipole moment by permanent dipole moment multiplied by the electric field. Increase key. And with a multiple of the electric field. Right? The dipole, the polarizability of the dipole moment alpha. The polarizability of the permanent dipole. The polarizability of
permanent.
So what is polarizability? It is the response of a molecule to external electric field, or the response of an atom to external electric field. So if it is a permanent dipole, still it will have a response to the external electric field. So here the dipole moment, the polarizability of a
Molecular.
permanent dipole, of a permanent polar molecule.
Yes, sir.
For example, I will say a water. The polarizability of water, that will be equal to its own permanent dipole moment square. The water molecule has a permanent dipole moment.
Yes, sir.
So you square it.
Divide by 3 k.
Divided by 3
3 k.
K. That is the polarizability. Because polarizability is alpha times E. So if we compare this from here, we can say that alpha is equal to
U square divided.
this thing. Say it, no?
Yes, sir.
The total polarizability will be, total polarizability will be alpha is equal to alpha naught plus alpha d, and that will be equal to alpha naught without an electric field plus mu square, right? And 2, the value, the atomic polarizability, and 3, K T. And this equation is called the Debye-Langevin equation. Debye-Langevin equation. Alpha naught is the atomic polarizability. Debye-Langevin
Sir, at a time when sir alpha naught we have alpha v.
نكن دون الفا نوت کو چې دا غي د اټمونو شو او بیا په خپل مالیکول دی کنه
No molecule کې atom نه لګي.
او په دې خو بیا د دې لکه دا اټمونو شو کنه اوس دې تر ګوره او دی کنه او دا H دی او دا اوم H دی او دې خپل پولارایزیبিলিټی ده
जी सर.
بیا د دې خپل
Yes sir.
بیا د دې خپل
Yes.
او د دې خپل جمع نه ده د دې ځان له دا هم جمع کېدو او بیا مو سره دام جمع کېږي چې د ټول ونه شوي د دې خپل مالیکول دا شو
Yes sir.
هغه دا
Alpha dipole.
څه شو دا
Yes sir.
یا د الفا ډایپول څه صحیح ده کنه
Yes sir.
خو کته الیکټریک فیلډ کې خو د دې شیزونو کې هم چینج راځي مثلا دې داسې دی لومبه نو دې په خپل هم بدل شي داسې شي او بیا به دې هم بدل شي او دا یو به هم بدل شي
Yes sir.
او دا به هم بدل شي دې وجه نه دې کې بدرې وړه راځي دا ټول راځي په نو شي وسم
Yes sir.
څه شي
Yes sir. Alpha not individual atom.
موږ وی کنه اوس دا دې نه مخکې بس دوه نه شي هم بدروم وي دا سره atomic polarizability ده نو دا کلیر ده نام
Yes sir. Clear sir. Clear. बस वही सर.
अब बस को
नामूज लोग बिया दो एक क्लास
अच्छा पास है
लाइक